In this video, I will be going over exponential graphs and exponential equations. So we'll talk about what makes an equation exponential and what that looks like on a graph. So first I have these two tables, and what patterns do you notice on these tables? So you might notice the x values are the same in both. And then look at the pattern with the y values, or the column that says f of x. So in this one, in the first one, to get from 2 to 5, we would add 3. From 5 to 8, we add 3. And from 8 to 11, we add 3. So we are adding 3 each time. In the second column, to get from 2 to 6, we multiply by 3. And then from 6 to 18, again, we multiply by 3. And then 18 to 54, we multiply by 3. So the first table is adding by 3 every time. The second table is multiplying by 3 every time. Now here I have the two equations for these tables. So the first one that's adding by 3 every time, the equation is f of x equals 3x plus 2. And that might look familiar. Maybe you've learned about y equals mx plus b. That would be a linear equation. So that's a linear equation where we are adding the same number every time. In the second one, the equation is f of x equals 2 times 3 to the power of x. Now we have x as an exponent. So this would be an exponential equation, because our variable x is the exponent, so it's an exponential equation. Here are the formats of those two equations. So I already talked about the linear equation is y equals mx plus b. So the exponential equation is y equals a times b to the power of x. So we have two numbers multiplying, and the second one is being raised to the power of x. And we will talk about what each of those components are. So maybe in linear equations, you remember that m was the slope and b was the y-intercept. So we'll talk about what a and b represent in exponential equations. So in the exponential equation, y equals a times b to the power of x, the a is what we call the principal. And you can think about that like the y-intercept. It is the y-intercept. But we call it the principal, and then the b is the rate. And you can kind of think about that like slope. So in a linear equation, the slope is the number that we're adding every time, right? And so in the exponential equation, we call it a rate because instead of adding the same number every time, we're multiplying the same number every time. So b would be the number that we are multiplying by. So in our table example previously, where we were multiplying by 3 over and over and over, then in our equation, b would be 3. And here is that example of that equation. So when we were multiplying by 3 over and over, that means the b value was 3. And then the a value was 2 because when x was 0 in our table, y was 2. So think about this equation. When x equals 0, then what does that do to the equation? Or what does y equal? So anything to the power of 0, so we have 3 to the power of 0 here. Anything to the power of 0 equals 1. So then we're left with 2 times 1, which equals 2. So that means this first number, whatever is in the a spot, that's going to be your y-intercept, because the y-intercept is when x is 0. So when x is 0, whatever's in the b spot, that will always just turn to 1. So then you'll get a times 1, which is a. So that first number will be the y-intercept. Here are a couple examples of what the graphs look like. So a linear graph looks like a line. That's why it's called linear. You can see there's the word line in there. So a linear graph just looks like a straight line. An exponential graph is a curve like this. Because if you think about it, the linear graph, it's just adding the same number every time. And so that's going to grow much more slowly than the exponential graph. The exponential graph is multiplying by the same number every time. So that number will grow very, very fast, and it will increase very quickly. And that's why the graph looks like that. So now let's look at what this looks like on the graph. And I'm going to make a table over here just to have that visual. So we already discussed when x equals 0, then 3 to the power of 0 is 1, and 2 times 1 is 2. And then when x equals 1, we would have 3 to the power of 1, which is 3, and then 2 times 3 is 6. And when x is 2, we'll have 3 squared, which is 3 times 3, which is 9, and then 2 times 9 is 18. So that's just plugging the numbers into the equation, but then you can also see our pattern over here. We're multiplying by 3 every time. 2 times 3 is 6, 6 times 3 is 18, and we had our table earlier, 18 times 3 is 54. Now these numbers are going to get really big really fast, and you're not going to be able to draw all of them on the graph. But just get the first couple points and you should be okay. So 0, 2, if we plot that on the graph, that would be right here. And then 1, 6. 6 is going to be up here. So over 1 up 6. So you're going to have a curve like this. Ooh, we didn't talk about negative numbers. Let's talk about that real quick. So I'm going backwards now. If we had a negative 1, so if you know your exponent rules, 3 to the negative 1 is the same thing as 1/3. So think about that. When you multiply by 1/3, that's the same thing as dividing by 3. So negative 1, it would be going backwards. So we're dividing by 3, so then we get 2/3. Because if we go forwards, 2/3 times 3 would equal 2, right? So it still follows that pattern where we're multiplying by 3 every time. Just thinking backwards, we would divide by 3 to get the previous number. Okay, so then at negative 1, we're going to go up 2/3. So about right here. And it's going to go out like that. So thinking about the rate, I asked the question, what are we approaching? So it's as x is approaching infinity, right? So as x right here gets bigger and bigger and bigger and bigger, remember this is exponential, so it is multiplying by the same number over and over, so it is growing really, really, really fast. So when you think about your graph, as you're going out towards infinity, this is growing really, really, really fast. And so this is going to go up towards infinity. It's increasing very fast, and it's going up towards infinity on the y-axis. So we talked about when your b value in this equation, when b is greater than 1, then your equation is increasing really, really fast. That's like this one. It's going up towards infinity, increasing really fast. We did not talk about when b is less than 1. So for example, if we had something like, this looks like maybe it starts at 10. So y equals 10 times, let's see, at 1 it's at 5. So that's about half, 1/2 to the power of x. So when your b value here is less than 1, so if it's a fraction or a decimal, then instead of multiplying, it's dividing. Or you can think of it like it's multiplying by a fraction, right? We're multiplying by 1/2 every time. So every time it's cutting that number in half. So we started with 10 up here. It cuts in half down to 5. So then at 2, it should be at 2.5 right here. So it's cutting in half over and over and over. So now instead of increasing really fast, now it's decreasing really, really fast. Because as we go out towards infinity, as x approaches infinity, we are decreasing. We're multiplying by 1/2, cutting it in half every time. So that's getting smaller and smaller and smaller. And if you think about this, where it goes out to infinity, it's never going to actually equal 0. Because if you keep cutting something in half, in half, in half, in half, it is getting smaller and smaller and smaller, and it's getting closer and closer and closer to 0, but it's never going to actually equal 0. It's getting really, really close to 0. You're going to get to like 0.00000000001 or whatever. You're just cutting it in half over and over and over and over. So it's getting really, really close to 0, but it's not actually going to equal 0. So as x is approaching infinity, y is approaching 0. And here are a couple more graphs. So here we have 1 times 2 to the power of x. That means our y-intercept is at 1 right here. So your a value is your y-intercept, so it starts at 1. And then this 2 is your b value. So that means we are multiplying by 2 every time. So times 2, times 2, times 2, times 2. And that's how we are growing that graph. And then on this one, your a value is 10, which is why you have your y-intercept right here at 10. Your b value is 1/2, so we're timesing by 1/2, 1/2, 1/2, 1/2, which means you're cutting the numbers in half, right? So if we have our table, x and y, so when x is 0, y is 10. When x is 1, we're cutting it in half, so that's 5. When x is 2, we're cutting it in half again, 2.5. When x is 3, we're cutting it in half again, 1.25. And so on. So every time we are multiplying by 1/2 times 1/2 times 1/2. I'm running out of space here. But you get the point, hopefully. You're multiplying by 1/2 every time. So we go 10, 5, 2.5, 1.25. We're cutting it in half every time. Okay, so that is just a brief overview of exponential equations and how to graph them. Hopefully this was helpful. Please like and subscribe if you liked this video, and please comment below if there are any other math topics that you would like me to cover in a future video. Thanks for watching.